Today we will derive the second equation of motion. The second equation of motion is S is equal to ut plus half at square, where S is equal to distance traveled by the object in time t, u is initial velocity, t is time, and a is acceleration. Let us consider the velocity time graph of motion of an object. So here we have the velocity time graph of motion of an object. The initial velocity of the object was u, and when an acceleration a is applied on the object for time t, the final velocity of the object becomes v, so from this graph we see that we see the motion of an object from point A in time to point B, and we have to calculate the distance traveled by the object in time t from this graph. So we know that in velocity time graph, the distance traveled by the object is given by the area under the graph in given time t. So the distance traveled by the object in time t is given by area under the graph in time t, and here the area under the graph is this figure, area of figure OABD. So distance traveled by the object in time t is equal to area of figure OABD, and this OABD is a trapezium, and it is made up of a rectangle OACD and triangle ABC. So area of rectangle OABD is area of figure OABD is equal to area of rectangle OACD plus area of triangle ABC. Now area of rectangle OACD is equal to base into height, and base is equal to OA into OD, base into height, and area of triangle ABC is half base into height, and base is AC into height BC. Now from the figure we see that OA is equal to U and OD is equal to T. So we write OA into OD as U into T, and this is plus half AC into BC. Now AC is equal to OD because ACDO is a parallelogram as a rectangle, and opposite sides of rectangle are equal. So AC is equal to OD and is equal to T. So in place of AC we can write T into BC. Now BC we can write BC is equal to BD minus CD, and BD is V, and CD is equal to OA is equal to U. So BC we can write, in place of BC we can write V minus U, V minus U. Now again, from the definition of acceleration, we know that acceleration is equal to V minus U upon T. So we can write A into T in place of V minus U. So here we can write U into T as UT plus half into T, and in place of V minus U we can write AT. So solving it, it becomes UT plus half AT square. So this distance traveled is equal to UT plus half AT square, and this is second equation of motion. तो इस ग्राफ में हमने देखा कि जब कोई ऑब्जेक्ट जिसकी इनिशियल वेलोसिटी u थी उस पर एक्सेलरेशन a लगी t टाइम के लिए और उसकी फाइनल वेलोसिटी v बन गई. सो इस टाइम t में इस ऑब्जेक्ट ने कितनी डिस्टेंस ट्रेवल करी ये हमें सेकंड इक्वेशन ऑफ मोशन बताती है. और इसको डिराइव करने के लिए हमें पता है कि वेलोसिटी टाइम ग्राफ, किसी भी ऑब्जेक्ट के मोशन की वेलोसिटी टाइम ग्राफ में डिस्टेंस ट्रेवल बाय द ऑब्जेक्ट होता है एरिया अंडर द ग्राफ इन द गिवन टाइम. सो इस केस में हमारा जो एरिया था अंडर द ग्राफ वाज इक्वल टू फिगर ओ ए बी डी, और ओ ए बी डी जो फिगर है उस दैट इज इक्वल टू आपका रेक्टेंगल ओ ए सी डी एंड ट्राइंगल ए बी सी. तो हमने जो है रेक्टेंगल ओ ए सी डी और ट्राइंगल ए बी सी का एरिया को हमने इस तरीके से सॉल्व किया, उसमें वैल्यूज पुटअप करी फ्रॉम द ग्राफ, एंड हमको सेकेंड इक्वेशन ऑफ मोशन एस इज इक्वल टू यू टी प्लस हाफ ए टी स्क्वायर डिराइव हो गई.